Okay, when I started Logicmoo, I definitely knew that I needed a virtual world in order to interact with the robot in. And so it needed to have assets and things in order to teach the robot. It also needed a representation of 3D space, the types of learning situations that would involve a teacher and a robot together to and challenges within a virtual world that using the robot's motor control, the ability to navigate and the ability to see things, and to be aware of objects that are pre-individuated and also not pre-individuated, that the robot could make decisions about what it would take uh, to gain some meaning out of the world. So ideally, we think of doing something like in Second Life, that we have absolute control of the 3D world. One of the bigger problems in that 3D world is whatever we want to interact with and the robot wants to interact with, we need to make sure are functionally complete. Like if we have a kitchen that we're trying to teach the robot how to, let's say, make a recipe, we'd want it to be almost realistic enough. Of course, that means that we have to have an ASOP pipeline, to create the type of interactive tools that we're going to need to teach the robot thing. And we feel like, that is a okay cost within the virtual world setting, especially how virtual worlds have increased in quality over time. So you can see in 2004, we have something's photorealistic enough to where we probably had enough, we have enough of an environment that we can create around the robot to get the realism we need. Whereas you see in 1983, we did not. And so with their dramatic improvement of simulation quality, we can create real and realer environments. So maybe this problem is not such a problem. But now let's take this other situation here where we have a real robot in which we can teach it about our world, like teach it about shapes and so forth. So this is a box, this is a pyramid, right, Zeno? Maybe we could do something like play magic with it, or poker, any sort of a situation that's real. So here we've solved the asset pipeline problem, and maybe we could draw shapes on the table and say, okay, Zeno, what shape is this? This is a circle. And then maybe even teach it a little bit of arithmetic. I can write, like 1/2 plus 1/2 equals 1. Or maybe even teach it about the shape of like how to cut a pie into several pieces, and it could learn fractions that way. Some of the limitations of the virtual world are completely gone here, right? I can now, let's say I want to take Zeno to the park. I don't actually have to take him to the park. I could take a video camera to the park, or I could take him to the park. Either way, point is that there's no limitations to the types of things I could teach this robot now that he's here in the physical world. But the real limitation is what is going to go into this robot's head right here. What conceptual structures had to be there for him to learn anything from this environment? So, of course, you can see that there's limitations to a physical robot and some limitations in VR. Limitations to physical robot is that it can't just be uh, put through the same experiences over and over without a virtual world. So if something took some sort of reinforcement learning, then we would have to do some of that reinforcement. If we were to take a robot that had even, let's say, what had human-like traits right now um, as a baby, and we wanted to train it to become a robot that we could ship, it might take us about 6 to 7 years from right now to put it through the type of human experiences it would take to become a human. So I mean, there's already an issue there. Now, if we could speed this up in VR, we would. But do we have that information right now? So there's pros and cons of the physical and the virtual. So the virtual is that it's just not real enough. There's too many. There's an asset pipeline problem. If we did make it as real as the real world, what if it took 7 years or 8 years for it to emerge human level capabilities? So even in the best case, the virtual world is going to push us behind a little bit, and the physical world is going to push us behind a little bit. So all in all, we're going to have to decide on the conceptual structures that go inside of the robot. And in Logicmoo, that's what we did. And we decided just for a moment, not forever, that we're going to forego the physical inverse optics problem that the robot has. That's where the same object from different angles might look a little bit different, or it's going to would have to learn that it is actually the same object. Just because it's been turned around, it doesn't mean that it's a different object, even if it's not present for the turning around of the object. Pretty much we have built into us the instinctual ability to do object separation. And there's a few things that we conceptually in our minds that we have that allow that to happen. We can assume, even if we're not pre-programmed, a lot of animals are pre-programmed, and our descent from animals show us that it's quite possible that we are pre-programmed with the ability to separate objects in the universe. And when critical studies of the brain show that, like by Jeff Hawkins, show that this is definitely the case. Logicmoo said, well, let's not try to build an actual biological being. Let's just build an AI that will be pre-equipped. We will have cheated solving certain problems. But I guess what people worry about is if you cheat solving certain problems, you might have cheated the qualia or all the details that go into building up to having those problems solved. That's definitely a good concern. And but I wanted to go through a process that addresses those concerns, but also gets past them. And so you're probably not going to like the solution that we came up with. So text only world. What's the advantage of this over these other two worlds? Well, in Logicmoo, my virtual reality world is generated through logical descriptions from a textual format. So, for example, if I need to build a dishwasher and a coffee maker, and say this coffee maker needs to run for 2 minutes in order to make a cup of coffee, and then I can do that in the text/hybrid 3D world. So if you're old enough to know what a text mud is, you know that they're pretty cheesy and faked. Sometimes it's not even real text. What I mean is, if it says there's something like you are in a, it'll describe a room with objects, and if you try to interact with those objects, it's going to say, I don't know what you mean. So for example, here there's a long counter that runs along the back wall. You might say, go tap your fingers along the counter, and you know what this is going to say is, you don't see a counter, because there is no counter here. So what Logicmoo did was, I described logically a real world, not a virtual world, with all the nuanced rules. For example, if there's a coffee maker and it takes 2 minutes to grow a cup of coffee, in Logicmoo, I declare that and it literally takes 2 minutes to make a cup of coffee in text, right? Well, it doesn't have to only be in text. It can also be in 3D graphics. The important part was that I could get everything that I needed within a virtual world in a textual format, at least. And it was pretty cool. That is like mostly finished, that part of the kernel. Well, I realized for my AI bot to be able to be anything close to what humans would have, it would have to have an imagination. And that imagination would need to be just as powerful as the game engine. So, in other words, I don't need just game engine just for the robot to experience the world. It needs to also be inside of its mind. So a MUD is a real-time multiplayer virtual world that's text-based. And from this text base, I could forego the asset pipeline and actually have more realistic objects in the text world than I ever could in a 3D virtual world. In a 3D virtual world, if I have to build a coffee maker, first I have to build the asset, and then I have to actually make it work like a real coffee maker. In Logicmoo, I can declare logically all of the mechanical details in the event calculus of a real-world coffee maker, have it work and operate all the nuances with rules. And that's what Logicmoo was initially for, was to create the ideal, complex as I could ever imagine, virtual world for an AI, a virtual world that was more realistic than any other virtual world. From that aspect, you see that you can create a much richer environment for a robot within that type of a virtual world than you ever could in a 3D virtual world. No, actually, I'm sorry, that's wrong. You could do that in a 3D world. It would just take 8 to 10 times the amount of time to do it in a 3D world, and no matter how good these games get, you're still going to have to put in the energy into that 3D world that you would have put into the text world. The only difference is there might be some eye candy for some humans. And so anyway, that's why I went with the text world. I can create something realer than I can in a 3D world. Okay, so it's a real-time environment for AI to learn in. So here's an example of what that learning process might look like. It's going through and experiencing these events. And right now, these are high-level written in English, but they didn't have to be. And I'll show you actually what the real perception pipeline looks like for the robot. All right, so the way Logicmoo works is it uses an event syntax. The robot at this point doesn't know that what's inside the cabinet, neither does the player. This is an event stream that happens in something that may as well be atomies. From this event stream that's going through, which I'm scrolling past, there are a certain set of side effects that are taking place to show like what the internal format of some of the physics are. a lot of inheritance and a type system that specifically to make this MUD easier to program that contains this. This is being generated through an event calculus, by the way. Some of it's prologue code, some of it's event calculus declarations for the virtual machine. The important part here, though, is back on our document. I wanted to give you just a snapshot. It is not actually, these are not the types of events that take place. These are the types of events that take place. Receive sexual events, and here's an example of a high-level thing I wrote, just so you guys can see how it works. Okay, so what the system is tasked with is automatically programming a simulator that will have the event stream in which it just experienced within the simulator, within that. So in other words, what it does is it writes a program that will output this into it. So this is the high-level version of what you saw on the other screen. So it consumes these, and it has to write a program in Simulator 2, which is its imagination. It needs to imagine what it just saw, but it does this in real time. Its job is to figure out what happened in Simulator 1 and emulate them in Simulator 2. That's just a restatement of this. So in this particular situation, it's going to be very naive and assume that this is the causality, that when Joe leaves to the north, suddenly Floyd, the name of our robot, is alone. And that's a result of Joe leaving to the north. And the way it does that is through the probabilistic method that I'm using to figure out that this event leads to Joe not being in here. Now, if Joe walks in and Floyd's alone, it makes Joe become present, and now in this room we have Joe and Floyd. So it knows that event 6 enabled event 7 enabled event 9, and 9, 10. It skipped over, 8, because it didn't need it. Anyway, so now when we run the program again after the training, we should be able to go into Simulator 2, put Joe and Floyd in the room, make Joe walk out the door, and then leaving Floyd in this room. So what we do is we confirm the training that after this state happens and this state happens, that this is the resulting state, when it's able to predict that. That's what the simulator process is about. But now we type in this room as Joe and Floyd. From experience of previous runs, well, that would have meant Joe came in through the north to get into the room that we're in. So in other words, this is a sensory process. This is the one that it started out with simulating on its own. And then we type Joe and Floyd was in the room. It figures out, it confabulates the memory that it adds this element into the story. So in this narrative, this is what's remembered. The actual events might have been that Joe came in from the south. The system didn't see that. So the system remembers, though, it creates an artificial memory of Joe entering the room from the north. And that's okay, because it's what humans do here on the slides. Okay. Okay, there's some problems with the system. So it's writing a program to take this text world and make an automatic copy of it on its own. It is supposed to be too perfect, but first we needed confirmation that it could actually predictively store the cause and effect relationships that it experienced in its virtual world. There's also times where it's not perfect, but we can always look at and say, oh, it did it imperfectly, it needs more training, and so forth. And I have a way of automatically doing that. We needed Logicmoo because we needed the insane flexibility that only Logicmoo could provide. And here's something kind of a little bit important, is the imagination system that the robot uses needs to be as complex as anything that the real world could present. So already we're in a case where we need something as Logicmoo's gaming system for it to use. Now it's not using its gaming system for its imagination. We're actually using the gaming system for its experience of the real world. But it's interesting, I want to see if the imaginary world can become as complex as the Logicmoo simulated world. And since I wrote the simulated world, I already know how simple it is. And it is simple. So really what it's about is a comparison of if that imaginary data structure can hold that I created for it. And if it can't, then I know that I've screwed up. And I needed that level of visibility in that to be able to check on this. I don't need something that's eye candy that looks like the real world, like we're seeing happening in neural nets. I need something that's actually logically realistic to the experience that it's having and the ability to compare it. Technically, if this thing did cheat and just did copy code into its imagination directly, its imagination would perfectly map. I wanted to find out if within the virtual world, can I create something in that virtual world that could actually act as the type of AI that I wanted our robot to be able to emulate? and then it could try to map the two together. The training program it's using, NARS, to be able to connect these two worlds together. NARS gave themselves a tough enough challenge that they would have to get everything right well enough that they could merge AGI. I didn't need NARS to be that good. I only needed to do virtual copying. I'm only using it as a system in order to make carbon copies, imperfect carbon copies even, and a way of doing a small bit of training. Now, if some of you know that OpenCog originally at some point, Novamente, I think, actually took a look at the NARS code and took the best that you guys needed. And I sort of did the same thing. And I reported it to my own programming language, which I created for Logicmoo. And so part of Logicmoo is actually written in NARS. Well, it's a language compatible with NARS. Even though it's written in Prolog, it has something to do with Prolog logic. Prolog was just the best general purpose programming language I could find. As a general purpose programming language, it worked out just fine. So I was able to create this system that would allow it to make analogies between using NARS technology, which is basically you could call it OpenCog technology, that could do this like complex sounding process. And I know you guys know it can be done because you can do it with your own code. The process I described to you a few minutes ago about that is actually done through this particular layer. It's layer system. This is something that NARS has not started to experiment with. And actually, it's a multi-buffer system that NARS is not using. For example, I'm elaborating my fake virtual world by using a non-axiomatic forward chaining system that annotates that. And so in a week or two, I should have part 2.